that okay?
Oh, you're all set.
So that's doing it now. Cool. So okay. So what did you guys want to talk about?
I mean, I haven't did 5-2 yet.
Okay.
But everybody's saying 5-2 is like this, like.
Wait, which ones did you do? Did you like?
I mean, I would just work on it like soon because it's like it's just kind of time consuming. Like, so again, if we have like, so okay, so here's the thing: if I have like this reference angle theta, right? Let's say this triangle is 435, right? Okay. So I'm taking what the sine of an angle means.
The y value of the.
So that's when we're talking about the sine corresponds to the y value when we're talking about the unit
over,
circle.
Hypotenuse.
Yeah. So the sine is basically the ratio of the opposite to the hypotenuse, and like
Is this 4/5?
yeah. And so, like I said before, these things exist because if I have a triangle with this same angle, and I only know this angle, I can't actually be sure about the length because I could build you a bigger right triangle, right? So even if we had this 3, 4, 5,
Yeah.
I could also build you a 6, 8, 10 triangle, right? Yeah, like that. So, but what it does preserve, what the angle does preserve, is this ratio between sides, right? The 4/5 is going to be the same as 8/10.
Yeah.
Right, you guys get that. 4
Yeah.
4/5 is the same as 8/10, right?
Stuff on here.
Yeah. Well, it's doubling top and bottom, so
No,
it's like
yeah.
the size of it isn't changing. The size of the ratio. So, so basically, I have these sort of like values which are absolute for each angle, right? These ratios. For each unique angle, there's only one like ratio between the specific sides of a right triangle. So I can't tell lengths, but I can tell at least the ratio, and that's like pretty good.
Yeah.
Because all that means then is if I knew one angle and one side, so let's say like this was 27 degrees and this was 7, I could tell you all the other angles. This isn't a right triangle. I could tell you all the other angles and all the other sides just using trig relations. Because I know, for example, that sine 27 degrees is going to be equal to 7 over whatever the hypotenuse is, right? And so if I wanted to know the size of the hypotenuse, all I need to do is do 7 over just a little bit of algebraic manipulation. I did that kind of quick, but so if I had some like table or maybe a calculator that told me what sine 27 is, I could tell you every time like what size the hypotenuse is. And, consequently, I could either use a Pythagorean theorem or I could just keep using my trig functions to tell you what the other side is.
I think I kind of get what you're saying.
So, okay. So, let's work from a specific problem. You got anything, Cliff?
Oh, no, I'm just checking a couple things out. I'll let you know.
Trying to pull out a problem for us to do.
Yeah.
Just checking. I'll let y'all know.
You have the computer.
Yeah. Exactly. So I'll get back to y'all.
No, like we know the problem from 5.2 on the computer.
I don't know. They look straightforward. If you ask me.
I mean, you have an 80, so let's do the ones that can do.
Nah, the ones is the ones you gotta use a calculator. That's
All right.
the ones I.
Yeah, let's do that then. Yeah.
Oh, okay. Well, I figured it out, but okay, we can. Yeah. So what was it? It was sine theta.
Okay.
Equals 0.5572. Yeah. I wanted the inverse.
Okay. So basically, what it's saying is we have some triangle, let's say theta's here, right? And there's some ratio, let's say this is 5.572 and this is 10. I don't know. Is that okay?
Yeah.
That's cool.
So basically there's this ratio between sides, right? And then we want to know what the angle is, right?
5.4/10. I don't know.
Well, so basically that would be what you would get from doing the sine of theta.
Okay.
So here, normally what we do is we input an angle, right? And we get out some ratio, right? We get out some number.
Yeah.
So for example, normally we would do something like sine of pi over 6 and get out 1/2. Or we do sine of, let's say, pi and get 0, right? Because here we would be talking about, let's say, like triangles where we knew the angle, and it'll tell us what the ratio is between the opposite and the hypotenuse, right?
Mm-hmm.
I would obviously need to know one length for me to be able to determine the whole right
Uh-huh.
triangle, because this could have also been like 2, 4, right? And that would have been the same angle. Is that idea okay, or is that look like you're confused a little bit?
It's cool.
So how exactly are you like saying that we'll be able to find like the ratio between the two?
Oh, so the sign tells you the ratio between the two sides. But I'm saying if you were actually looking for the lengths of the sides, you would need to know one of the lengths. Right, because the ratio here is still the same, 1 to 2 and 2 to 4. It's the same ratio.
Mm-hmm.
But if I just knew I had an angle of pi over 6 and nothing else about the triangle, I couldn't tell you what the lengths of each of the sides were, right? But if you told me all of a sudden, okay, this length is 7, then I know, okay,
If
so
I'm
the
not
hypotenuse is
mistaken,
14.
That length, this is the adjacent, right?
That's the opposite of this,
Opposite.
because this is the angle right here.
That's the hypotenuse.
Yeah. Mm-hmm. So if I knew one side length and the angle, then I could say, okay, this side's 14, right? Because the sign tells me that it is. The sign tells me the opposite to hypotenuse's ratio is 1 to 2.
Oh, okay, I get it now.
Yeah.
I get it.
So normally we're just doing signs of angles,
Mm-hmm.
right? We're inputting an angle and it's telling us what that ratio is. Here we have side lengths, right?
Yeah.
And we want to know what the angle is. So we need a new function, basically. And that function is the inverse function. So we write it like this. Or sometimes it's called arc sine.
So the inverse function of opposite over
Right.
hypotenuse.
Yeah. And here the opposite over the hypotenuse is 0.5572.
Mm-hmm.
Right? So I would, either way, if my calculator has arc sine or it has sine to the -1, which just means inverse sine.
Yeah.
It's not 1 over sine also. This is why I specifically said I don't like this sine squared type of convention, because it makes it look like the inverse sine is 1 over sine, and it's not that.
It sucks.
It's just a function that does the opposite of what sine does.
Okay.
But anyway, so basically I would sort of just like plug it into a calculator, Cliff,
Yeah.
and tell me what I got out. So I think for
that's 34. 34 degrees.
30. Oh, you put it in degrees. Did it ask in degrees?
No, well, that's, the home end.
Oh, did it?
Before that, yeah, what I gave you.
Okay.
34 degrees. Yeah.
Okay.
Well, it was screwing me up.
Yeah, so yeah, if you want, you need to be able to, you need to know how to flip your calculator between like radians and degrees to tell it to give it what it asks you,
I
basically.
had to read the directions.
And so the arc sine is just the same thing, right? It's the same function. Just does the inverse. So basically, I know now I know from these ratios, like I should be able to, what this angle is, and now I have a function that does it for me. So for example,
You want another one?
I'm just gonna create another one. So for example, if I had a triangle here, let's say I'm going to put the angle theta over here now. And let's say I knew the side lengths were 7 and 10. And I want to know what the angle is. So I definitely know I can know what the angle is because two side lengths basically tell me what the whole lengths of the triangle are, so there's going to be like angles associated with that.
7 squared.
Yeah, so you could I could figure out the other side from like the Pythagorean theorem. So 10 squared equals 7 squared plus b squared, right? So 100 equals 49 plus b squared. B squared equals 51. B is the square root of 51. So that's this side length. Okay, but I'm mainly interested in the angle. So how can I figure out what this angle is?
The angle.
What the angle is? Yeah. So I think you were sort of saying that you need like an inverse function, right?
To find the angle.
So why don't I set it up at least?
Yeah.
With using like a regular trig function, if that makes sense. What were you gonna say, Alex?
I was gonna say, like, wouldn't it be like adjacent over hypotenuse?
Yeah, that would be the easiest because, right, like we knew 7 and 10 right away, right? So adjacent over hypotenuse, ADJ over hypotenuse, is going to be
15 squared over 10.
Wasn't this the adjacent though?
Oh yeah, you're right.
7 over 10, right? And adjacent over hypotenuse is what trig relationship?
Adjacent over hypotenuse. That's cosine.
Yeah, it's the cosine, right? So in other words, the cosine of theta is 7 over 10. Right? That's the ratio.
I need the angle, so it has to be the inverse.
Right. So I want to do the inverse cosine of what?
7 over 10.
Yeah, exactly. So I do the inverse cos of 7 over 10 is going to tell me what theta is.
What's up?
It's just scientific calculator.
Oh, you said what?
So do the inverse cos of 7 over 10.
So basically, to find the angle of something, you just need to do the inverse.
Yeah.
Of whatever relation
whatever
you have.
relation you have.
Point
And then
7953988.
9, 5. Okay, so I'll just leave it at that.
Yeah.
So theta is about 7.95, and I assume that's in radians.
Yeah.
Okay, cool. So yeah, so then we're done. That's it. And
so
you
the
can
ratio is just the relationship, and the angle is the inverse relationship.
Yeah.
Yeah, you would do the inverse trig relationship to find what the angle is. So Cliff,
Yeah.
do for me the inverse sine of the square root of 51 over 10.
Oh, square root of 51.
Yeah, the
Over
inverse
10.
sine of the square root of 51 over 10.
Okay.
The square root of 51 over 51.
Yeah. Over
10.
10. Yeah. Got it. So that would. So I don't know why I said error domain.
Okay, let me see.
Let
Let me
me
see.
say that.
Yeah, the dollar sheet scientific.
Yeah. Nah, man.
Wait, did we do this?
Yeah. Technical issues.
The square root of 51 is less than 10.
Yeah.
So the arc sine of
I must have
the
missed
square root of 51 over 10. Oh, I think, did you do it inside the square root sign?
something.
So what's the answer?
Oh, okay.
7.9.
Oh. Oh, so when you said square root, I was tripping. I put squared.
Oh,
Not yeah.
yeah,
Silly
okay.
me, yeah. That's what happens when you skip breakfast.
So what do you think, Alex?
Yeah.
About like
So you got the same answer, it seems like. Is there a reason for that?
Whoopsie.
isn't that like when you like multiply and you like say, oh never mind, I'm thinking about something else, sorry.
Okay.
Hmm.
So here I did the inverse cos of 7 over 10 to find the angle. Here I did the inverse sine of the square root of 51 over 10. And we got the same angle, right? Same value.
How's that though? If,
Yeah.
Because 7 squared is 49, not 51. So how would it be that we got the same?
Well, we said this other side was the square root of 51, right?
But then, like, what I'm trying to like ask is like, okay, 7 isn't this isn't like a root of like 51. Like you can't go like 7 times 7 and get 51.
Right.
You get 49.
Right.
So how come is it that it's like 49 divided by 10? Like, for example, like this squared divided by 10 and this divided by 10. How does that give us the same thing?
Yeah, because you're saying the inside is
yeah.
different values, right?
Yeah.
But am I doing the same function?
No.
Right. I'm doing the inverse cos. Here I'm doing the inverse sine, right?
But still, does that really mean anything?
Well, so what is the inverse cos telling us?
It's just telling us the inverse of these numbers give you its angle or whatever.
Right, but what numbers did I use specifically when I did the arc cos?
You did 7 and 10.
Because?
Because those were the angles. Well, those were what we already had for our lens.
No,
That was the
Jason
Jason and the hypotenuse. Yeah.
Yep.
So then, wait, but there's no triangle. Wait.
Oh.
We're using the same numbers.
Okay.
So then that would be opposite
That makes
over
more sense.
hypotenuse.
Yeah, I think I get it now. Yeah. Okay.
Right.
Because you did this inverse of sine, which is opposite over hypotenuse.
Right. So I use these numbers specifically because it's the opposite over the hypotenuse. And so if I
Yeah.
did the inverse sine, it should still give me the angle, right? Because it's the same angle.
Yeah.
Does that make sense, Alex?
Yeah.
Yeah. Because if I'm doing opposite over hypotenuse, I could do so. Basically, I could do the arc sine and use these to give me the angle, or I could use these and do the arc cos, and it'll still give me the angle, right?
Yeah.
And I could even use arctan if I wanted to. I would do arctan. So if I did, what would I do the arctan of to get the same angle? Or let me just be consistent here and say tan of the this one.
We'll do opposite over adjacent. I mean.
So okay, so if I did the arctan of square root of 51 over 7, what would I expect to get?
You would get
The 10 or arctan?
Arctan.
okay. So
What do you think, Alex?
Mm,
The root of 51 over
Wait, you need to
7.
close that.
Close this one right here.
Yeah,
Right?
yeah, close the parentheses there. Yeah, and now over here.
7. Negative 1.62. That doesn't sound right.
No, it doesn't sound right. Hold on a sec. Oh, you did. Wait, you just threw a negative in there. Hold on. Oh, you did the tan. You need to do the inverse tan. Like that.
Oh, 0.79.
0.795 radians. Because?
Because it's adjacent over.
Because you use the adjacent over, or the opposite over adjacent,
Over adjacent.
and that is the like relationship of tan for that angle.
That makes sense. I get it now.
Okay, and then let me do an even further fact here. So what if I did? What do you think would happen if I did now, instead of the cos of 7 over 10, or the inverse cos of 7 over 10? What if I did the inverse cos of root 51 over 10?
Okay. So I'll give you. Okay. The inverse cos of root 51.77. 775.
Okay. Now I want you to do something else.
Mm-hmm.
I want you to do pi over 2 minus 0.775.
So, okay. Over 2. Minus 0.775.
Huh?
0.79. Wow. What the hell? Just came back to that same number.
Yeah. Why?
That's crazy. Is it because it's over 2? Wait, what? That don't even make no sense.
Right. So okay, so think about what I'm doing here when I do the inverse cos of root 51 over 10. So what is that telling me when I do that arc cos?
Whatever it is, it's going to be there. Inverse cos of 51. That's crazy. I actually don't know. I feel like I might know, but I don't know how to say it.
What do you guys think? Help them out. So Alex, what is this? The square root of 51 over 10. Where did I get that from?
you got that from the sign, right? So that was hypotenuse over, not hypotenuse, opposite over.
Yeah.
You got that from doing the Pythagorean theorem, or use like 10 square.
Well, why am I doing the inverse cos of it?
To see if it like remain the same, like what will happen.
Sort of, yeah. I'm trying to see what the change is. So if I'm doing the inverse cos of root 51 over 10, what angle am I getting?
So,
So here the cos of this angle would be 7 over 10, not root 51 over 10, right?
if you was doing root 51 over 10, wouldn't it be that angle at the top?
Yeah, exactly. So I'm going to call that angle phi. So the inverse cos of this angle, the inverse cos of root 51 over 10 tells me this angle, right?
Yeah.
And the reason I did this was because phi plus theta need to add up to what?
7.95. Whoa.
You have a right triangle, right?
45 degrees.
Close. So this is 90, right?
Mm-hmm.
So if I add up the other two sides, what do they have to add up to?
180.
Well, the whole triangle
The
has
whole
to add up to
triangle.
what? So these two sides would just need to add up to what?
Oh, the 90.
90. Or, if I wrote it in radians,
In radians, 2 pi radians is 180, so just
2 pi radians is
I mean
360.
360, so 1 radian, like 1 pi radian, wouldn't that be?
So pi radians
Pi
would be
radian is 180.
180. So 90 would be,
Half of that.
yeah.
You.
Oh, okay.
There you go.
I see what you got. I see what you did here. And then when you did the like radians part, that's when I actually like understood what you was doing. Like,
Yeah. Mm-hmm.
I get it because
So-
that would equal the same thing as.
Yeah,
Okay.
this has to work because you're just doing the other angle essentially. I'm doing the arc cos to find the other angle, and the other angle and my first angle have to add up to pi over 2
Huh.
because it's a right triangle.
That was simple.
You.
All right.